All right, so today is just a wrap up of the course. As announced on Piazza, there won't be a lecture on Thursday, but we will still hold help hours, the lab help hours for any last minute items and for any, getting help on assignment 8 and your design document. But otherwise, today is just going to be a short course retrospective here. And what is a retrospective? Well, it's from industry. What you do is at the end of a sprint, we'll talk about that in a moment here, is you reflect on what went well, what didn't go so well, and what can be improved for the future. So I kind of do a retrospective at the end of each week, like it's a weekly retrospective, but then I also do one at the end of every assignment, right? And then also post each lab and what went well, what the common mistakes, et cetera, et cetera. So your opportunity for a course evaluation or a course retrospective is the course evaluations, right? And now I do take these seriously. We often make changes based on suggestions from students. This course is rather mature, so not a lot of changes are made, but if we did make changes, we would have to prioritize and say, well, what gets cut, right? And so your positive feedback on what was the most helpful thing to you is also a value, right? Don't just say what bad happened, like this is what you should retain basically in this course. So make sure that you're filling that out because again, if we reach 75%, we're at 50% right now, we'll go ahead and tack on 20 points bonus on the starter points there. So we're currently at 50%. We just need exactly 4 more people to fill this out, and we're good, right? But it has to be done by Friday, though, right? Because that's when the end of the course is. So now is your time to reflect on the course and where have you been? Compare yourself to the start of the course, And because it's the end of the academic year, also compare yourself to the beginning of the academic year. For many of you, you're freshmen, so this is your first year. There's always a great quote that I give from a previous student in one of these course evaluations, where they reflect on themselves and say, you know, when I came in at the first of the year, I couldn't code anything. Right, I constantly had to look back and forth in documentation, and now as I am leaving the first year or getting done with the first year, I'm a coding machine. So think about that, right? Think about your improvement over the years, because you know we'll get to it here in a second. But you might have done some things bad. You have made some mistakes along the way, but that's part of the process. What have you learned though, right? So hopefully you've improved some of those soft skills, like teamwork, especially if you chose to team up with a partner, right? Conflict resolution, you know, partnerships don't always work out, right? And sometimes you also have to set expectations, or you have to learn to communicate, because part of a successful team is knowing how you work and understanding how you work, and then knowing how other people work and understanding how they work, so that, because not everybody works the same way that you work, right? I can tell you that now, having taught this course and been in academia for 15 years, right? Procrastination does not go away. I still have colleagues that are working up to the final moment of grant deadlines or paper deadlines or something like that. I don't work like that, right? And I'm not naive enough or have the unreasonable expectation that everybody works like that, like I do, right? For example, the last paper that I submitted, it got assigned a paper number 0001, which told me that is not a ranking or anything. It's just because that was the first submission, right? When the submission's open, I submitted it, and I was done, right? Of course, they're going to get a flood of submissions right before the due date, right? But understanding how you work and understanding how other people work so that you can mesh well together, right? And you know, my teammate in that doesn't always work diligently, or you know, all the way, front loading stuff. And so I've learned to, you know, communicate and send reminders about what needs to be done and when, right? In fact, one of those soft skills that I learned a long time ago, and that I've used to this day, is setting what are called drop dead dates. So this is something that I adapted from agile software development, where you know somebody wants you to do something, right? And you can say, well, I can do that if this dependency and this dependency and this dependency, these things that I depend on, are done by this date. And if they're not done by that date, my commitment automatically disappears, right? And those are drop dead dates, because if it doesn't happen by that date, I'm dropping it, it's dead, right? And I'm not committing to that. Making sure that you organize not just yourself, but others and external things that you don't control. That's all part of those soft skills: coordination, planning, organization, and time management, right? Hopefully you've increased your toolbox here, right? For many of you, it's going to be your second programming language, Java. Third programming language, as SQL. SQL is a programming language. For many of you, this is your first time with object-oriented programming, right? And it might be the first time that you used Git, but you should be using that on a daily basis. It is such a useful tool that I use it for stuff unrelated to computing at all. For example, I like baseball and I like scoring baseball, but I hate the typical scorecards that you can buy in stores, so I made my own. Where do you think I put it? I wrote it in LaTeX, by the way. Where do you think I put it? On Git. So that when I go to the store or Kinko's or whatever, and I need to print some more scorecards, what do? I just go to Git, because the PDF is right there, right? Being able to make changes to assignments or labs or something like that, committing it and pushing it, and it's immediately out there. Everybody should have this skill. In fact, Git is only 20 years old, but the concept goes back even further than that. Before that, we had SVNs. Before that, we had CVSs, content versioning systems. So it goes back 40 years or so, right? Only in the last 10, 15, 20 years have other people, other disciplines realized that cloud management and version management are a good thing. For example, Google Docs or Microsoft documents where you've got collaboration, right? It took forever to get that kind of stuff integrated into applications like that. We've been doing it for a long time, right? As in like computing professionals have been doing it for a long time. Pretty much anything in the modern world comes from computing people, right? For example, hashtag, 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 right? That's now a common thing that grandma even understands, right? Where do you think that came from? IRC, Internet Relay Chat, right? That hashtags were used for channels, right? You would know it today as Discord. Discord is nothing more than a web interface to old school IRC channels that have been around since the 70s, 80s, right? So we've, truly computing people have been the pioneers of everything modern, right? It's just that not everybody knows about it. Hopefully you have experience and perspective building a larger project. Like I've told other folks, that this is not really a large project. That's why I put it in the quotes there. It is certainly not a week-to-week assignment like you might have experienced in a computer science 1. It builds on prior phases build on each other. But once you get into a capstone course, right, or like a larger project-based course, you'll find that these projects start growing. When you get into industry, these projects will, and you look back on this project that you did this semester, you'll say, oh, that was nothing. I can push that out in a week, or probably in a day by then, because that's what I did. I just made the project in a day, and along with a solution key, right? But that's because, I've got experience, right? Once you have that experience, you'll find that large means millions and millions of lines of code, right? Hopefully you've got some experience now technical writing and using this design document, right? Like we said when we brought in, I've not been able to get the Writing Center at UNO to come in and help me with it. But in Lincoln I did, and we saw that thing that we cited came from them originally, of employers, right? What are the necessary skills of new graduates? And then what are those skills that are completely lacking? And it's always writing, right? Can't even write a coherent email, right? If you can do some basic technical writing and you can write a coherent email, that puts you head and shoulders above a lot of other folks, right? So again, I like introducing this as early in the curriculum as possible, and that's why I have an IEEE, 1086 design document for this course. Right? Hopefully you have a better appreciation of technical debt. Technical debt is eating your own dog food, right? If you don't do it right the first time, you're gonna either, 1, find time to do it over, or 2, you're gonna be fighting that bad design the entire rest of the semester. In other words, if you serve up dog food, you're gonna have to eat it, right? If you create something bad, then you're the one that's gonna have to be maintaining it for the rest of the semester or the rest of your career or something like that, right? This also pertains to policy. We'd always tell managers, that wanted to do a certain policy. For example, nowadays it would be work from home. No, you can't work from home. We need you in the office. Oh, is the manager in the office? No, they can be remote. Oh, okay. Why aren't they eating their own dog food? Right? Why are they setting policies that they themselves are not adhering to? That's actually a good litmus test in real life, right? Are they doing it themselves? If not, hypocrisy, and really question why it's happening. Right? Bad practices hopefully become apparent why they're bad practices. Design as an afterthought rather than first. Again, just investing a little bit of time up here on a whiteboard, drawing out your ideas and sketching them out is going to save you way more time later on, because you realize, no, it's not going to work because this, and this, right? We still had folks that had not fixed their sale class design, for example, to have a list of items in the sale class, which made assignment 7 impossible, right? Not just difficult, but impossible. Because if you can't ask the sale a question of how much is your total or how much is your taxes, then there's no way that you can sort by them, right? So again, design should come first rather than as an afterthought. Hopefully you've realized that having good tests, not just necessarily a not even just a formal, unit test suite, but at least, testing your function, right? Does it actually work? Don't rely on the web grader. In the real life, there's no such thing as a web grader, right? You're writing the code and you're writing the tests at the same time. That's test-driven development, okay? Hopefully poor variable names. Hopefully you've broken ideally you never got into the bad habit to begin with. But if you got into that bad habit, make sure that you're breaking yourself of that as soon as possible. If you've got result set 1, result set 2, RS1, RS2, RS3, right? What the hell is RS3 again, and when do I close it, right? That's not gonna work out, all right? You're going to lose the forest for the trees, and then you start piling bad on top of bad, right? You can go too far, right? And remember, Yagni, you ain't gonna need it. Don't over-engineer things, right? Bad database design. Some people were living with that all the way up to the end, right? Hopefully you have, again, better appreciation for the scope of a larger project, working and coordinating in teams. You're better coders overall, you're better designers, right? Unfortunately, a lot of people still hit some impediments for this course. Generally, it's never really getting started, right? If you look at a grade distribution week to week of this course, and I'm not just talking about this course, but I deliver a 150-person version in Lincoln, a 30-person version in Lincoln as well for an honor section. And this is almost universal, right? What you see is everybody's getting an A up until week 4. Why? What happens in week 4? Assignment 1, right? And then it drops down here, and it stays the same for the rest of the semester, right? It's not like a traditional course that's what they call it, formative or summative assessment, where you have like 2 or 3 or 4 major exams, and that's 90% of your grade. And when you hit that first exam and you bomb it, right, then you're done for the semester or something, right? No, folks in this course that don't do well never really get started, right? Or they get started and then, but they have whatever difficulty and almost immediately after that drop off. Again, procrastination is never a good formula for success. Again, I say that even though we've got some highly successful individuals that I work with in our own departments, and they still procrastinate, but they're never putting in their best work, right? Don't worry, we'll fix it in the journal version of the paper instead, where there is no due date, right? You just keep iterating on it until it's good enough to get in. But hopefully you've seen, did anybody use the Gantt chart faithfully? Okay. The Gantt chart is over, I think it's 150 years old. It dates back to the Civil War, I think. Don't quote me on that. We'd have to look that up. Somebody can look that up. But it is still used to this day. Why? Because it makes sense. You have a due date. You work backwards from that due date, knowing and estimating that it's going to take me this long to do this, and I have to do that. I have to do this other thing before that, and I have to do this other thing before that. It allows you to backwards plan and say, no, we're not going to meet that due date. Or, yeah, we're going to meet that due date if this happens, and this happens. You have a little bit of exposure to agile development. Even though we didn't talk about it, this course is set up as an agile development process. Meaning that in real life, if an agile development would be that you have, say, 4 weeks as what's called a sprint. At the beginning of that sprint, you commit to what you're going to be doing for that sprint, that next 4 weeks. The theory here is that it protects you from mismanagement. A manager can't jump in and say, oh, priorities have changed. We need you to work on this thing now. Or, nope, sorry, you're going to have to wait until the end of the sprint, right? It protects you from bad management and bad planning because you're doing all the planning. You're going to they can prioritize things and say, generally we need this thing and this feature first and this feature second. And the team is responsible for breaking that down and saying, we can commit to that in this sprint, or we can commit to a part of it in this sprint and then the rest of it in that sprint. And you assign points to it. And throughout this sprint, this 4 weeks, you have what's called a burn down chart. You start up here with the amount of work that you have committed to, and by the end, you should have 0. Ideally, this should be a nice linear curve because you are working at a nice, even pace. You don't have these spikes in productivity and these troughs where you're not doing anything. It would be terrible if there was no activity, and then finally everything was crammed at the last end, right? That's usually how it works, unfortunately, for poorly planned things. It would also be bad if, you had immediately dropped off in the beginning and then you didn't do anything for the rest of the month, right? That was you saying, yeah, that's going to take us a month, when it didn't take you a month. It took you one day, right? Of course, you can hide that, but you generally don't want to do that, especially if you've got competent managers, right? But agile development is for a team-managed kind of setup where you don't have non-software people coming in and telling you how to do software. Instead, you have what are called stakeholders or product owners coming in and saying, we have these priorities, you handle it, right? And then you come back and say, we can handle it and we can do it this way, right? And you commit to that because it's supposed to be a truthful assessment of how much work there is. And then at the end of your development process, right, at the end of that sprint, you have a retrospective. What went well, what didn't go so well, et cetera. And again, design comes first, right? If you are procrastinating, then that means that the design doesn't come at all, right? You're trying to cram everything in at the end. There should be, in this burn down chart, there should be a little bit of design. There should be a little bit of implementation. There should be a little bit of testing, and a cycle of that stuff throughout that process. Right? Insufficient testing is also a big impediment, right? Again, if you can run code, then you can run tests. If you can write code, then you can write and run repeatable tests. If you can read code, you can write proper unit tests. Right? Now, this is a cognitive development here. Right? This first one is the lowest cognitive rung. And as you progress, as you get better, as you get more experience, then you progress up to the highest level of cognitive ability here. Reading code is actually way, way more difficult than writing code. And writing code is way more difficult than just running code. Anybody can run code by following step 1, step 2, step 3. Right? All right. These are the skills objectives that I enumerated at the beginning of this semester. You should be able to now we need to reflect. Did we achieve these skills? Are you able to more easily pick up a new programming language on your own? Right? Probably. Maybe your next one will be Python. Right? That's quite popular. Otherwise, if you want to get into game development, then C# and Unity, or C++ and what's the other one? Unreal, thank you, Unreal Engine, right? Although that's more visual the way it's set up. But you can write in C++ there. What else would that be? I guess if you want to work in a lot of locations in Lincoln and Omaha, there are a lot of .NET houses, which means C#. Right? C# would be Unity as well, too. What did I say first? Unity. Did I say it? C#? Okay, hopefully I said C#. You used to be able to do it in JavaScript, but that's been deprecated, and for good reason. But if you want to do web programming, JavaScript, right? That's always useful. By the end of your matriculation, by the end of your graduation, you should have, I don't know, at least 2 core languages that you are really, really familiar with. Another 3 that you're kind of familiar with, but maybe not able to use on a daily basis. And then maybe another 5 that you've seen and that you've at least written a Hello World program in or something. So that you're when you actually get a job, you can say, yeah, I know a little bit of that, and here I can take a test on it at least. Give me 24 hours to brush up on it, and you can pick it up really, really easily. Why? Because you've had exposure to so many programming languages by the end. You should be able to recognize, use, and design and appreciate programs with an object-oriented flavor. Even if a language is not object-oriented originally, eventually they all add that feature. Python didn't used to have classes, but now they have classes. It also works the other way. Java was always an object-oriented programming language, but guess what? They added Lambda functions and other functional programming language kind of concepts. And given a long enough time, every programming language starts to look like every other programming language. The one thing that they don't have in Java yet that I really like to see are coroutines, though. A coroutine is a function that you can pause, right? So here's a function with 4 things in it, right? You can say step 1, step 2, step 3, step 4. But what you can do is you can say step 1, step 2, pause, and give control back to whatever function wants it, right? Eventually, it'll come back into this function where you paused it and then continues. That way you can put it into a while loop, right? All right, do step 1, step 2. Pause for 5 seconds, right? Now, that doesn't freeze the program. It just hands control over to anybody else who wants it. All right, and then it comes back in after 5 seconds, does step 3, step 4, goes back up to the top of the while loop. Step 1, step 2, right? Those are coroutines. JavaScript has them. I think that they're called generators. Don't quote me on that. But that's one thing that I wish Java had, right? Because it basically gives you asynchronous programming without worrying about synchronicity, right? It's basically out of the box asynchronous programming. Right? Why would you want to do that, by the way? Anything that you want to be humanly noticeable. For example, I want to fade this box from red to green, right? And if I just immediately did that, right, then a human wouldn't see the transition. Why? Because there are 256 steps in changing the color. But those 256 steps on a computer are immediate. But if you did each step in say, a tenth of a second, then over time you see the transition as a human, right? And that's one of the applications of it. Would you say that as a whole, the class is where it needs to be? We just lack experience. I lack confidence. The only thing that compare my, never. So my advice there is never compare yourself to anybody, especially instructors. Compare yourself to yourself, right? Because if you start comparing yourself to other people, first of all, you don't have a good picture, right? You're comparing yourself to their highlight reels, their successes. You never see their failures, right? So never ever compare yourself to other people. Compare yourself to yourself. Here's where I was at the beginning of the semester. Here is where I am now. Yes, that's a marked improvement, right? You should be able to design a database-backed application from scratch, given a general problem statement. You should be able to understand and implement basic data structures, as well as recognize when and how to leverage appropriate data structures. Being able to see, nope, if I use a linked list in this loop, it's going to take me 20 years to do that. Versus, no, if we replace that with an array list, or I replace that with appropriate code, now it'll take 3 seconds, right? When can I bring a heap in here to take care of all this for me? Put stuff in, take stuff out, right? 4 lines of dumb code, but smart data structure over there. And of course, be able to identify and analyze basic algorithms. That's big O analysis. Again, the theme of this course is from Eric S. Raymond. The smart data structures and dumb code are a lot better than the other way around. That's from the Cathedral and the Bazaar. It's kind of a treatise, philosophical view of software, right? You might think, well, software development, software engineering, whatever it is, it doesn't involve philosophy, does it? It's either works or it doesn't, right? It either compiles or it doesn't. No, there's an entire sub-discipline of thinking about code and what code should look like, right? And what a programming language should look like. Because given 2 distinct designs, there might be advantages here and advantages here, disadvantages here, disadvantages here. You have to think about it philosophically, because just by looking at it, yeah, we could go with either solution, but we need to explain ourselves, or at least think about it. And philosophy is nothing more than the act of thinking, right? Thinking about something. At the end of this course, you should approach a reasonably complex problem and ask design questions first. What entities or objects should I be able to create as building blocks? Instead of taking the problem and breaking it down immediately, I'm going to look forward and think about design and think about what building blocks, what classes should I create in order to model this problem. Then, how are those objects going to interact with each other? We should do composition over here. We should do inheritance over here. We should do a separate static class over here for various reasons. What data structures would be the most efficient to use? Right? Those kind of questions. Go back to assignment 1. Did you use a data structure? If not, think about how you could have done assignment 1 with a data structure instead, like say a map, right? How would a map made that basically trivial, right? In fact, in one of the sections I go back and I do assignment 1 in Python, showing how you can just use a comprehension as a one-liner and get the entire assignment done with 1 line, right? Now, that's not advocating for Python. Doing something straightforward like that as a one-liner is pretty easy in Python, but the second that you're doing something that's not straightforward like that, then it becomes way more complicated, right? So Python is good for simple stuff. It ain't good for complicated stuff. Again, the big takeaway here is that you may have done some or a lot of things poorly, but it doesn't matter because you'll do better. Right? This is why we build in those resubmission opportunities into this course, because of course we know that there's going to be procrastination. We do know that there's going to be a bad design or two. We want to encourage you going back and reiterating on that design, and we allow that resubmission. The other takeaway here is if you're a computer scientist, if you're a computer engineer, which is everybody in here, or if you're a software engineer, or adding to this list now data scientist, and maybe in, I don't know, 4 or 5 years we'll add robotics engineer on that, or actually I would prefer mechatronics. Have you ever heard of mechatronics? So take a mechanical engineer, an electrical engineer, and a computer engineer, combine them into one, and you've got a mechatronics engineer, right? That would actually be really, really cool, right? But whatever. Anyway, whatever you call yourself, everybody in here needs to be a little bit of a lawyer, a philosopher, a diplomat, a manager, designer, creator, writer, thinker, and programmer, right? I put programmer last, right? Because as you progress in your career, and if you think back to this entire semester, the amount of time that you spent on programming was probably equal to the amount of time that you did of these other things. Right? You might have been doing 2 or 3 of these things at once, right? But certainly as you progress in your career, the amount of time that you go and do programming is going to be eclipsed by the amount of time that you're doing those other things. So why do I mention lawyer first? You have to be a little bit of a lawyer. You have to be enough of a lawyer to know that you're not a lawyer, right? The example that I'll give you is that in the last year, I personally got a copyleft troll demand for money. Have you ever heard of copyleft trolls? So you use some like free image that's been released under a Creative Commons license, but you don't cite it exactly the way that it should have been cited. The creator then signs up with this copyleft troll company of lawyers that automatically sends out thousands and thousands of these letters, just hoping that somebody is dumb enough to actually pay them, right? And that's how it works. And so I immediately got this letter, and other responsible parties also got the letter. It was just an email notification. I knew enough that, no, I'm not a lawyer. I'm not going to say a damn thing. I'm going to keep my mouth shut, because that's exactly what lawyers tell you to do, right? Never, ever talk to law enforcement. Never, ever talk to another lawyer or somebody representing some legal entity without getting your own lawyer, right? And so I immediately just forwarded it to the general counsel. And the general counsel said, yeah, we'll take care of it. We're just going to send them a stock response of, no, we do not pay out on this. Go ahead. And because I also knew that how we were using it would fall under a fair use clause under the US code, right? Unfortunately, somebody else in the process took it down, took down the image, and also forwarded an apology. Oh, sorry, we've taken that down immediately, sorry. One thing you do not do is ever say you're sorry in the US legal system. Why? It admits guilt, right? This person was not enough of a lawyer to know that they were not a lawyer to shut the hell up, right? And refer the matter to a lawyer, right? In fact, there are 2 great lawyers on YouTube. I forget who they are, but they have a great YouTube video of Shut the F Up Friday. It's your weekly reminder to shut the F up and lawyer up as quickly as possible, right? So you do have to be a little bit of a lawyer to know when you're not a lawyer enough to send it on to an actual lawyer, right? And the other great video that I like is I posted my CS1 courses. If you are ever a contractor in a contractor position, right, get a lawyer, because you're not enough of a lawyer to do what lawyers do. Contractors that do not have a lawyer, it is so easy to take advantage of them, to not pay you, right? And the second that you have a lawyer, guess what happens? 99.999% of them pay you, right? You just need a lawyer up, right? And the video that I'm thinking of is F you, pay me, right? And it's this one consulting firm with a bunch of contractors and their lawyer, and they're talking about their history and how, you know, they were constantly getting screwed. That they would do these projects and they would then not pay because, oh well, that's not what we really wanted, right? Well, no, if you pay me, talk to my lawyer. Yeah, it cost. The one thing that they harped on was, yes, the lawyer costs. They cost $100, $200, $300, $600 an hour, but the amount of money that they get back from by extracting through the legal system, it far exceeds their costs. Right? So everybody has to be a little bit of a lawyer. You have to be a little bit of a philosopher because you have to think about code. You have to think about the proper way of doing things. You have to be that diplomat because those soft skills, communication, conflict resolution, understanding yourself. The latest term is emotional intelligence, right? It's just understanding yourself or understanding others, empathy, right? Being able to understand how other people work and being able to work with that, right? Or more underhandedly, understanding how people work and think so that you can, you know, getting people to do something that you want them to do is so much easier if they think that it's their idea, right? So being able to communicate in such a way that you get somebody else to think it's their idea, that it's a good idea, right? That's being a diplomat right there. Managers, of course, you have to self-manage and you have to manage everybody else. If you teamed up, you found out that it was not half as much work. It was probably actually more work because you are now responsible not just for yourself, but you're responsible for your partner. You are responsible for communication between both of you. You are responsible for everything, right? Didn't I do this yesterday? Yes. If you are an internet rando that just walks into 3 different sections of a course, yes. Right? So you do have to be a little bit of a designer. You have to be a little bit of a creator, a thinker, a writer, of course, because of design documents. And only at the end do you have programmers. Right? Here are the final stats for this course. It's about what it looks like in last spring. Hopefully we'll increase this this enrollment here in Omaha, but that's basically what it was last year. Again, I'd like to see an improvement on this still, but there are the stats for the others. Right? It's a typical ratio. Again, this has only started in the last 2 years, so this is the second offering in Omaha of this course. It's a comparable distribution, maybe slightly better overall with respect to the average, the mean, right? All you have remaining are assignment 8 and the design document, and hopefully if you've been submitting design document drafts and getting that feedback, it should be 99% done at this point. Of course, there's no final exam because there's no exam, there's no quizzes or anything like that. Once you turn these 2 things in, you are done for the semester. If you turn them in early, that's fine. We ain't grading them early. Right? We're going to wait until the Friday deadline. Right? Where do you go from here? Unfortunately, I'm not too familiar with the UNO CE matriculation, but I do know that you got lots more circuits, right? Right? I do know that you have a CS3, 3320. Either you take it next year or you take it in your 3rd year. And for that reason, I would say keep frosty, right? Make sure that you are learning new languages and keeping up with data structures and algorithms. Because if you end up skipping it for a year and then go into the CS3 and they start talking about trees and hash maps and stuff like that, and oh, we did that 2 years ago, but I forget it now, right? Stay frosty, right? In other words, keep up with these exercises. A long time ago, at UNL, it used to be that you would have one programming course and then you would get through the next 2 or 3 years without being forced to do any programming. I'm like, that was terrible. I mean, we're talking before you guys were alive, so don't worry about that. At least over 20 years ago, right? But in any case, maybe you have a discrete math course, I don't know. But I don't know about the content of this. You can ask Paul about it today. He'll be up there to help you today, but unfortunately I won't. I've got a meeting, but I will be there Thursday, and he won't be there Thursday. So use this time to say goodbye to Paul and thank him for all of his help this semester. Otherwise, what do you do professionally? Does anybody have an internship for the summer? 1, 2, 3? Sure. Oh, but you got an offer?
Most likely, yes.
All right, yeah. You just, are you accepting the offer? You have to work on those details, right? Okay. So good. If you have not had an internship, it's late to apply, but it's not too late, right? I say that because, not all internships positions get filled, or they make an offer, and then, no, I don't like those details. No, I'm going to go somewhere else, right? And then they magically have a new position available that they're scrambling to fill. And so it is still possible to apply for these things. Again, everybody in here after the first year is more than qualified for at least one internship after their first year. If you don't get an internship this summer, get one in the fall. If you don't get one in the fall, get one in the spring, or in next summer 25. Right? But otherwise, if you don't, then always at least learn a new language, build a new project, do whatever. Right? There are a couple of suggestions I can give you, but I guess you can join our Discord if you want to, but that's for UNL. There is a college level Discord, but I don't think it's very active. But you can go ahead and join us there. You can always look at Bits and Bytes. It's publicly published. I don't think that ECE has something like that, like a weekly newsletter. Yes? No? All right. It does? Inspection? Spectrum? EE? You want to know? What's it called? Oh, it's IEEE? Okay. Yeah, go. Otherwise, it's the internet, isn't it? Whatever it is, stay in touch because they at least if it works like our Discord or Bits and Bytes, they will publish it throughout the summer along with job listings. Right? UNL uses Handshake. Do you guys use Handshake? Or get on that if you're not. Get on LinkedIn if you're not already. Because you are building a public profile through there. More than likely you will get headhunted at some point maybe, just by your profile. At the very least you'll get an email from Facebook or something. Hey, please apply over here, right? Or something, right? Again, I want to thank everybody who took this course. Thanks to everybody who helped on Piazza. We didn't have any learning assistants. We just had Sophia and Paul as our GTA and UTA. But I'd like to thank them for all their help this semester. When you see them today, thank them if you go up there. Otherwise, if you just see them in the hall, thank them. And thanks to everybody who took this course that continued the in-person and anybody online that just went online, stayed online. And have a great summer. So. I will see you on Thursday, unless you're done with everything, and then I won't see you on Thursday. But otherwise, have a good summer.